Okay, in this short video I'm going to show you how I had to go at optimizing the fuel map tuning of my Chinese diesel heater to get it burning most efficiently. And if you're the sort of people who want to have a crack at that in a cost-effective and pragmatic way, this may be of use. And what I mean by that is we all know, because it's day one at nursery school, what you do is you buy a gas analyzer and you shove it up the exhaust, blah, 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 blah. But personally, may not be the only one in the world, I really don't want to spend more money on a bit of kit to tune it than the heater itself cost me. Okay, now there's loads of people out there with gas analyzers who think I'm wrong, but that's my take on it. That's how I'm proceeding forward. No need to mention gas analyzers in the comments. Okay, now full transparency, like everyone in the world who has only installed one or two of these heaters, I am no expert, okay? There's plenty of people on Facebook who think they are, but I'm not one of those people. So I come up with a method based on Hess's law, and this is where I need a bit of help from the community because I'm not 100% sure on this. So that I'm welcoming any input on this. Tell me where I'm getting this wrong, because I'm not a chemical engineer. My primary degree was mechanical engineering. Yeah, I've done some fluid mechanics and come across Hess, but not enough to be an absolute expert. And in any case, that degree was an awful long time ago. And no comments such as no shit Sherlock are welcome in the comments. So what I did is I thought I had to find a way, and I messed around with lots of things, and what I came up with, which seems to work quite well, is I used what's called a K thermocouple plugged into my multimeter. Okay, now loads of people are going to have these because they built their own vans, and most of them will have a temperature setting. The actual K probe, you buy these on eBay about £5. Okay, so it's no money. If you haven't got a multimeter with this on, with the temperature setting on, you can just attach probes to the end of the thermocouple and look at the resistance. However, not ideal because it's not a linear sort of one-for-one change of resistance equals change in temperature, and the multimeter deals with all that. So, but these aren't expensive these days anyway, are they? Not like gas analyzers. Oh, I said I wasn't going to mention gas analyzers. This is a theoretical combustion equation for kerosene. It doesn't matter if it's diesel, 28-second heating oil. They're all in the same family. You can all run those in the diesel heaters and swap them in and out. So you can see you've got the kerosene. And you burn it with oxygen, and it produces carbon dioxide and water, and the exotherm the exotherm from that process is about 7.5 kilojoules. That's the heat that's coming out of that chemical equation into your van through the burn. Excuse me. Okay, that's ideal, but in reality what happens is this. Okay, you also get CO, which is carbon monoxide, which is what the people with the gas analyzer, I'm not going to mention those. You also get C, which is carbon, and if it's badly tuned, you get a lot of that and it soots up. Okay, and the more of those unwanted you get, the less energy comes out of that equation and turns into heat to your van. So the better it's tuned, the more heat output you'll get, which will result in less carbon monoxide and carbon, etc., etc. Okay, so that's it. Now, right, so how did I go about it? Well, what I did is I shoved the end of my thermocouple up the heat output inside my van, and then I had it running, and then I moved the probe back and forward until I saw the highest point temperature on my multimeter, and I clamped it at that one. Now, I must say, when I first started thinking about this, I was going to try and measure the heat output by just measuring the temperature of the body, the heat exchanger, with one of those infrared thermometer gun things. But the more I thought about it, I thought you've got heat radiating out of that. It might cause, it might be more prone to error than putting a thermocouple actually in the constant airflow itself. I think I'm probably right on that, but again, we welcome any comments from you guys. Okay, all right. So that's the starting point. Now, maybe your heater, you've just got it, and you can't get to fire up at all, it's just white smoke coming out, because that's what happened to me. Because we all know, you don't buy these things from the manufacturers, you buy them from box shifters in China, who get a batch in, they shove it in with bits of crappy tube and that sort of thing, flog it off to you, and for all you know, they might have bought a batch of heaters that were destined some high altitude place in China, and it's not going to work from day one. So when you see people on Facebook saying, Mine works straight out of the box, and I've had it going for 3 years and I've never touched settings. You should never touch settings. Well, good for them, but some of us, we have to touch settings, and some of us want to touch settings because we want to optimize it in any case. All right, and but what I would say is, if yours is working, make a note of your settings, because if things go wrong, you can put it back to it, and that is the last patronising bit of nonsense I'm going to come up with now. Right, okay, so if you have got a problem and you can't go in, try using these settings. That's what I did when I first kicked off. I went onto Facebook and got some settings. I'm not sure if it's these ones because it's about 6 years ago now, but this will get you going. I can see from the figures that they're close to what I've got on my heater now, so that should get it fired up. If it doesn't, you've got something else wrong with your heater. Okay, so do a screen grab of that if you need it. Now I'm going to go into the van and start playing. Okay, so these are the initial settings I put into the controller. Now it's hard to make these videos short and punchy, and I've made the assumption you guys know how to get into the controller and adjust the fuel map. But in case you don't, there's a link at the top now you can click on, and I'll put it again at the end of the video if you want to watch this through first. Okay, so that was my kickoff settings. All right, and the idea is we do a tune at the lower speed range, and then we do a tune at the higher speed range, and we rely on the algorithm of the controller to set the settings between those two. I had intended to start with a lower fan speed than that, but 1450 RPM was the lowest I could get it. And of course what I should add is I've got the smaller body 2 kilowatt heater with a 0.16 mil pump, but I'm absolutely sure this principle will work for the 5 kilowatts if that's what you've got. So having done that, I fired up the heater on the lowest setting, 1.0 Hertz, and when the speed of the fan dropped down after it got up to temperature, I left it for another 10 minutes to stabilize, then took a temperature reading which came out at 126 degrees centigrade. I should add now that every time I made a settings change, either to the fan or the pump, I waited another 10 minutes for it to stabilize. So this took quite a long time, okay, but I left it 10 minutes for the temperature to stabilize. So now I say, well, let's assume we're running it a bit rich. We'll increase this fan speed to 1550 and see what happens. But after 10 minutes, the temperature actually dropped to 123 degrees centigrade. So actually, I'm thinking it's not too rich, it might be a bit lean. So then I dropped the fan speed back down to 1450 and increased the pump speed up to 1.1, and after 10 minutes, by coincidence, it was still 123 degrees centigrade. So it looked like, by good chance, the initial low speed settings I had were the optimum fuel mix, and so I locked those at 1.0 Hertz pump and 1450 RPM fan. Ran it for another 10 minutes to let it stabilise, and though it didn't get up to 126, it did get up to 125, which basically looked into my mind that, yeah, we got the right kick-off setting at the lower end of the range. And then moved on to the upper range. So back to the main panel on the controller and crank up the setting to 5.0. Leave it for 10 minutes, and then I saw I had a temperature of about 199. It flickered between 199 and 198. So then I thought, well, maybe we're running it a bit lean. Let's richen it up a bit by dropping the fan speed. Left it for 10 minutes, but the temperature did actually drop to 196. So I think it's not too lean, maybe it's too rich. But to be sure, I took the fan speed down another 100 to 4400, left it for 10 minutes, and sure enough the temperature did drop further to 189 degrees centigrade. So I thought it's definitely not running too lean, maybe it's running a bit rich, so I reset the fan speed, fan speed back up to 5000 RPM and dropped the pump down to 4.8 just to see if we get a little bit less juice going in, and sure enough the temperature actually went up again to 203 degrees centigrade. So I tweaked the pump speed down to 4.6 Hertz, and sure enough the temperature went up to 205, so we're going in the right direction here. So we're getting close, I think, so I took the pump speed down one notch to 4.5, and the temperature went up a little bit more, fluctuating between 206 and 207. We'll give it the benefit of the doubt and call it 207.
So I took it down one more notch to 4.4, and this I thought was quite interesting because the temperature kind of plummeted 4 degrees. So actually it was between 4 and 3. It was fluctuating between 203 and 204. So clearly I think we just hit the right setting on the trial before. So I cranked the pump high speed back up to 4.5 again and leaving it there. So that's my final settings with the tuning. Tuned to the bottom end, tuned to the top end range, and trusting that the algorithm in the computer will do its best job to get the fuel mixes right between those two.
Okay, so that's how I went about trying to optimise the fuel air mix ratio across the spectrum on my Chinese diesel heater without the use of an expensive, I won't mention the GA word. I will actually. If I had a gas analyzer, would I have done a better job? I don't know. Certainly, you know, the thermochemistry theory works. It stacks up and it seemed to play out on the ground. Time will tell, but the initial results seem very good. I've run that heater right across the spectrum from 1 up to 5. No hint of a white smoke at any point, so it seems to be burning clear. One thing I did check is that when I was down at 1 hertz, because that is quite a slow spit of diesel into the burn chamber, but the body was getting up to the required temperature. I had the 2 red bars, so all is good there. So yeah, if you want to have a play, have a go. Yes, if you do need help on how to get into control or to mess with your fuel settings, there will be a card at the end of this video. You can click on how to do that, along with a couple of other. I've got a video on how to pair your remote if you want to do that, and how to pair more than one remote. Perceived wisdom is you can only have one remote paired. There is a way of doing multiple remotes, that's on there, and also a text switch, how you can turn your diesel heater on from your mobile phone using a text switch. So that's great if you're coming back from a walking or get it fired up 20 minutes before you get back to the van or something like that. Anyway, all the best.